a deal gone wrong if someone says, I want to be flawless, and then the other person's like, well, I'll make you invisible, and then they're like, well, maybe, and then they find out that he was just erasing them. And so that's a deal gone bad. I've had an air intake in my car, and the most funny change of winds, it felt like a giant kinematic bomb went off. So I know how important it is that the air quality inside of an engine is equal to parts of a spark plug if it isn't any oil in it. I have no oil in my car, and the more that I run it, it's getting the motor dried out and chipped up. Well, it doesn't have any liquid for those chips to go in, and so it's basically just gonna bottom out the spark plugs. What's a platelet? You know, your entire body is like straight as a board, but if it was a capacitance plate, it would be like a really conductive surface. So you might have been scratching your head, I know I was, when I said that there's drawing of light. It's utilized better the more that it's at a distance. And here's why. When stars twinkle, it's an illusion. Well, not really, but you can see the difference, whoa, of the sun not twinkling, unless it's in a full rotation. But stars do twinkle because they're so far away, despite the stars and the sun being the same thing. Well, what's the difference, bud? Here you have a frog. A frog sees light as it twinkles. That's in its most organic form because light is in packets and they're always interacting with things, meaning that they're being absorbed, or the opposite of absorbing, emitted. And so when a frog sees these lights, or any light, it's of little dots and they're popping. There's nothing wrong with that. It's actually how it should be. It's just the only time we get to see it is in stars that are twinkling. So at a greater distance in drawing with light, if you're moving it around, I was just assuming you would be able to see it like a giant light beam, because it's easier to see the giant light beam if it's in a lighthouse at a distance. Which is why when they say if hell freezes over, I'm trying to think of a literal explanation of how the earth would resemble that, and it would be as the tectonic plates would find their, what would they think would be poles, because the earth's magnetosphere would be broken, so they would be confused, and so they would be trying to form a dipole respected to the other tectonics that survived, so they would be mimicking either north or south, and they would probably try to spin as well, but the liquid under them would be solidifying, so it would keep them from spinning, so they would actually probably achieve the magnetosphere in each corner, which they would have a few of them, being that the plate tectonics are more than just one, like a hybrid of a vacuum. If you can read a register, you can write anything. Someone say that would happen when hell freezes over. I'd say that would be an occurrence if Earth entered the belly of the beast. Yeah, that would look something like if the ground was breathing. Whereas if Earth were to enter the similar constraint, it would probably be aided in by a massive swamp, that of which would be a bridge that would house the gap, probably equaled out from all the electron activity that it's built up. Tectonic plates, that's probably what it's been trying to achieve the whole time. After the plate tectonics have already been broken. That's been set in stone. So the reverse of that would be them to equal out in their solid state positions, almost as an atom has an 8-octet rule where the electrons feel safest in their symmetry of 8 electrons, and that's a certain shape. So once the plates settle in their geographic locations, it would be the exact opposite of where they were first set in stone in Pangaea. So if that wasn't an occurrence, it would ostensibly break the Earth's magnetosphere. What would that look like? Well, it would go haywire and then shut out, almost the same as, and as it's shutting out, it would be going haywire on its way out. Because when earthquake, it has a aftershock, and then it has the pre-shock before. The arrow being shot is a whole bunch of minor arrows that are earthquakes, but one giant arrow shot would be if all the plates were satisfied in their desolate locations and they stopped rubbing against each other. So it's like a ticking time bomb, except it doesn't. Perhaps the reason why earthquakes are an occurrence, well, we all know it's because of the plate tectonics, where the driving of the plate tectonics is the magnum in the center of the Earth spinning. Well, what if that is driven by the jump of the entire magnetosphere each 300 years? Makes sense to me. There's constantly activity because there's so much action happening. On Earth, there's always vibrance because it's not all dried up yet. Also, the magnetosphere of the entire planet shifts every 300 years. It does a 180, North Pole to the south and vice, meaning that it's on a time threshold of doing it, is always able to be estimated. Seismic scales are things that earthquakes erupt, and this has been, people for thousands of years have been looking at the ground trying to figure out what makes it rumble. It's only recently they figured to make some scales, and that's how they've come to understand magnitudes and timing of earthquakes. We're going to go a step further. What rocks your world? Nowadays, there's been an invisible giant who has been heating things up, very much as when plates rub together to make earthquakes. And so the more accurate that you understand the sediments of rocks is watered down soil acting as liquid when it's shaking in an earthquake, or rocks acting like elastic bands in an earthquake as they recoil, the more that you can start understanding the excitement inside of the things that are acting like rubber bands or liquid that aren't bands or liquid, is the molecular structures in them and the things that are residing inside the molecular structures. Each state has their handful of minerals, and it's a science of understanding what's happening to them during an earthquake, which is directly involved, as they're all shaken differently depending on their molecular structures. The things inside of them also influence them. Arthropods are these tiny little insects that are hairy, and they're thought to be the first, the hairy ones are thought to be the first that have been come up from the ocean onto land. And these are moving fossils. Yeah, they're actual tiny little insectocytes that are classified as fossils that are living. So there's that.